Okay, so 15.2 solenoids. This is like the second half of the last video. And what you want to be thinking about here is you want to be thinking about that right hand grip rule from last lesson. Okay, so we're going to need to use that, but this time we've done something a little bit cleverer. Okay, instead of just having a wire, this time we've got a wire that has been turned into a coil. Like so. Now, if I've got a wire that's been turned into a coil, what that does is that concentrates that magnetic field that we saw in the last one. So this one here, see, I've just drawn the one circle around there because I've just got the one wire. It's a really weak magnetic field. But if you imagine that you've coiled up that wire nice and tight with lots and lots of coils, okay, you kind of concentrate that magnetic field, and you're going to change the shape of that magnetic field because they're going to start to affect each other, a bit like we saw when we put the two magnets together. Okay, you're going to get some start where it's going to start to affect each other if you've got two magnetic fields. So this magnetic field from this wire starts to interact with itself, and it creates a funny shape. Okay, but we're still going to use that right hand grip rule. Okay, so, oops, sorry, can't do that. Okay, so if I know that that's my right hand grip rule, you can see I know that my wires are going to be going like that. Okay, so I know that I'm going down, going down, going down, down, going down. Okay, so each one of my coils down, 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 down. Okay, now the way to think about this now is that so you've got two ways of doing it. I'll show you both of them. Okay, so this one, as you can see, that's that arrow there that's going down there, and this is that arrow there. That is myself, and if you look here, this one is and this is why I don't like this one too much, because you have to change your perspective for this last one. So, and it's that last one that doesn't quite make sense. So that one's your North Pole and that one's your South Pole. This one makes total sense. This one's your South Pole, which means that this one must be North Pole. But the other way of doing it is by thinking about in terms of which way the field lines flow. And you can tell which way the field lines flow just by gripping hold of the wire. Okay, so the next thing you've got, so if you imagine that if you grip it there, look, you've got your current flowing this way, the magnetic field's going to be going around here. Okay. And if this is going in here, what the red lines show are the magnetic fields. Okay. So it's spiraling in, and if you remember, they always start at the north and go to the south. Okay, so that fits with what we know already. Start at the north, go to the south, and you can see that that one's the south one. This one here is known as the devil's tails rules. And the idea behind the devil's tails rules is that these bits here, they look a bit like a devil's tail. Okay, so that's that one, and that's that one. And if it's got this one going up here and this one going down here on the first coil, that's your start and your end point for your S. Whereas if you're going down here, that's your start point for your north. Okay, so I know that this one's my South Pole and this one's my North Pole. And the other thing that you can note is that, remember the square that I said, so if you had a square here and you want to know how strong the magnetic field was, well, you can see that the magnetic field is going to be very, very strong inside the solenoid, and outside the solenoid it's going to be not so strong. So in here, look, it's 3 times stronger than here, because here you'd be cutting through 3 field lines, here you'd only be cutting through 1. Okay, and that is a basic electromagnet. Now, there are 3 ways in which you can make this stronger, and they are: 1, increase the current; 2, add more coils, basically more of these here. You put these coils tighter together, so you've got greater density of coils. That will increase the magnetic field strength, because you've basically got more. Each one of these coils gives you 1 bit of magnetic field, so the more you have, the more magnetic field you have. 3, add an iron core, and what that is just a bar of iron which will go through the middle of here. It'll concentrate those field lines, and then that makes it even stronger. Okay, so there are the 3 ways in which you can make it stronger. And if you were investigating a magnetic electromagnet, what you'd want to do is you'd want to change one of these 3, but make sure you kept the other 2 the same. And the other factor that could affect it, which you'd also want to keep the same, but it won't make it any stronger or any weaker, is the temperature. And that's more to do with a property to do with electricity. So the higher the temperature, the lower the current will be. So you've got to keep the temperature the same, otherwise your electromagnet's going to get weaker. Okay.